So next up, we're doing section 4.3, which is about some translation properties for Laplace transforms. And before I list out what those are going to be, I just want to say real quick that we're working on Laplace transforms for a while, and it's a difficult topic. So if you didn't do some of the stuff from last week, you really need to stop right now, go look those things over, make sure you have a solid foundation for Laplace transforms, because the problems we solve are just getting more complicated from here. But if you're ready to move forward with Laplace transforms, what I'm going to say is that you should kind of take what I'm about to write right here and add to your little reference table of Laplace transforms, like L of 1, L of cosine, things like that. Have these new properties that you're willing to refer back to at any time. And then we'll practice using all of them as we go through these sets of videos. The first is that the Laplace transform of e to the at times f is equal to capital F of s minus a, where we always assume that L of little f is capital F. And then sort of conversely, L inverse of f of s minus a is going to be e to the at f of t, for L inverse of capital F equal to little f. So just like last week, you can copy down the forward and backward direction of these properties, or you can just copy down one and then know that the inverse is the same. L of f of t minus a times u of t minus a is equal to e to the minus as times f of s, where u of t minus a is a step function. And we'll talk more about that later, but for now, just write in your notes that it means that it's a function that's 0 whenever t is less than a, and then it's 1 whenever t is bigger than a. Actually, I think we'll do it this way, where the equality is on the one side. It doesn't actually matter which of those two things it is. And of course, the inverse is true. L inverse of e to the minus as, capital F of s, is equal to f of t minus a, u of t minus a. And then something that's going to follow from this directly is if you just wanted L of u of t minus a, that would kind of be L of f of t minus a, u of t minus a for f equal to 1. So it's just going to be e to the minus as times 1 over s, because that's L of 1 right there. So I'm just going to write it like this. So that's convenient. And so these are all the translation properties that we'll be talking about. And you should plan to just copy them down in your notes somewhere for easy reference when you're working through problems on your own. And instead of having the usual intro sort of written out for you in advance, I thought it would be better to write all those things out during the video because you need to be writing them too. And the thing that kind of ties all these together is that they're all properties that help us sort of shift Laplace transforms or functions across x or s values. You should be familiar with the idea of translation from like f of x to f of x minus a from like an algebra class. So when we say translation properties, that's the sort of thing we're talking about. And so the rest of these videos are just going to be working through examples. And I'm going to go ahead and stop here for an easy way to break things apart. I feel like we could get through the first example on its own, but better to just make it its own video.